Good morning, Year 10s. Today I would like to have a look at two-way tables with you. So this lesson or this video is all about how you can create a two-way table and how you can transfer information from a Venn diagram to a two-way table. Now, first of all, before we can create a two-way table, we need to know what a complement is. So let's say we've got an event A, and my event A is having an iPhone. And the complement of that event would be not having an iPhone. You can write different things for the complement. You can either have it as an A with a little dash or an A with a horizontal line. Sometimes you even see an A with a little C up in the index. So there are different notations for that. However, all of them mean not A. So in our example of event A being an iPhone, not A means not having an iPhone. Okay, once we've got this clear, we can now start creating a two-way table. My example is I'm having two events and they are overlapping, and those two events are having an iPhone or having a Samsung mobile phone. Now my event A is having an iPhone and my event B is having a Samsung. And what I will now do, I will organize data in a table where you have a column for A and also a column for not A. And you have a row for B and a row for not B. And when you draw the vertical and the horizontal lines, you get a total of 4 boxes here. Those 4 boxes those 4 boxes represent the different relationships between A and B. So that are those boxes here in the center. Those 4 boxes create different relationships between A, or represent different relationships between A and B. And what are the outsides for? Well, the outsides are simply for the totals. So when you have so many boxes, you can put the totals in everywhere. Now, let's say I have a Venn diagram that represents my information and I want to transfer the Venn diagram into a two-way table. Or maybe, yeah. So, got a Venn diagram. A is iPhone, B is Samsung. So there's 3 people that have both. 6 people that have an iPhone only, so that means there's a total, remember, of 6 plus 3 people that do have an iPhone, so that's 9 people. And I'm having 4 people here in the circle for B. So remember, that also means that there's 4 people that have a Samsung, but there's another 3 people that have a Samsung as well as an iPhone, so there's a total of 7. And there's 2 people on the outside. Those are the people that have neither an iPhone nor Samsung, so they would have a mobile phone of another brand. Now, what does my two-way table say? It gives me this. The first column stands for A. Now, the first cell here is A and B. So if you read it horizontal, you see that that's in the B line. If you read it vertical, that's in the A column. So that gives me the event A and B. So A and B at the same time. So that would be those people that have both. So for our example, I draw another two-way table that actually has all the numbers in here. Now A and B, well, I've just said that means both. And both is the intersection. So those are the ones here in the middle. So that's a 3. Now, what are the other 4 fields for? So first of all, let's do this. In the next column, we have not A. Well, that's not A. And the second row, that's not B. So that means not A and not B. Well, not A and not B, that's all the people that have neither an iPhone nor do they have a Samsung. That's exactly those two here on the outside. So we can shade everything of our Venn diagram. That's neither an iPhone nor Samsung, and that's exactly 2 for this example. Now, what are the other two fields for? Well, you've got the first column here, A, and then the second row that would be not B. So it means people in our example that do have an iPhone, but not a Samsung. And for this example, the people that have an iPhone and not a Samsung would be those 6 people here. Because the 3 people here in the intersection, they do have a Samsung as well. So iPhone and not Samsung, that's this circle here. Looks a bit like a half-eaten cookie. That's 6. And now we can check the totals here very nicely, because we've just said, well, from our Venn diagram, in order to find out how many people have an iPhone, you need to add the 6 and the 3, that gives 9. And you can now see that in the table in the same way. So 3 plus 6 down the column is 9. That's my total. Now we can also investigate what does it mean, or how many people do have not an iPhone but a Samsung. Let's see if I can find another color here. So as having a Samsung, that's circle B, and the 3 people here in the intersection do have an iPhone as well. So that means those 4 people here, they would have not an iPhone, so not A, and a Samsung B. We can check the totals here as well. So for the circle B, there's 3 in the intersection that do have a Samsung, and the gray bit here is 4. So that means there's a total of 7. You can read that off the table as well. That adds up nicely. And there's 2 more totals to calculate. So the people that do not have a Samsung, that would be a total of 8. 6 plus 2. And the people that do not have an iPhone, that's the 4 and the 2 going down vertically. 6. Now what's the total? We've got 7 and 5 here, that's a 15. Well, that's good. And down horizontally we got 9 and 6, that's a 15 too. So we do not put 15 plus 15 in here, so 30. We would rather only put 1 15 here. So that's a total. I mean, now from the table we can read off the total that for this survey there have been 15 people surveyed. Out of those 15 people, 9 have an iPhone, and subsequently 6 not an iPhone, because 15 minus 9 adds up to 6. And 7 people have a Samsung, and 8 people do not have a Samsung. And the interesting bit is here that we can read off the intersection from the first cell, A and B, and we can read off the complement of that, not A and not B. Now, last lesson we have also investigated the union. So when we said A or B, in order to find the probability of that, what you've got to do is you need to find the probability of A plus the probability of B and subtract the probability of the intersection. So the probability of A union B, A or B, will have to be the probability of A plus the probability of B minus the probability of A intersect B. What's the probability of A? So you need to find the total of all people that have an iPhone. Well, we just calculated that. That's 9. But that's 9 out of 15. Remember, we give probabilities as fractions. Now, what's the total number of people that have a Samsung? Well, that would be the first line here, B, so that's 7. 7 out of 15. And now, but if you would just add the 9 and the 7 up, what you would get is more people, because you would count the intersection here twice. you would count the 3 of A and B for the 9, and you would count the 3 again of A and B for the 7. So that's why we have to take it away again. So we have to subtract it as we had a double in here. So the intersection is 3, both is 3. So that means we've got a total of, on the probability of, well, 9 and 7. That's 16, 16 minus 3. That is 13 over 15. That's the probability of having an iPhone or a Samsung. And that also makes sense because there's only 2 people there on the outside. So there's 2 people who do not have an iPhone or a Samsung, and 13 15s plus 2 15s adds up to 1. And as I've showed you in the last video, the complement and the event, they always add up to 1.